Gold shines for centuries, iron builds bridges, copper carries electricity, metals run our world, and non-metals like oxygen and carbon keep us alive. In this chapter, we'll compare metals and non-metals, watch how metals react, rank them by the reactivity series, see how ionic bonds form, and learn how metals are pulled out of the earth and protected from corrosion. From scratch. Start with physical properties. Metals are usually shiny. They have luster. They are hard, malleable. They can be beaten into sheets, ductile, drawn into wires, good conductors of heat and electricity, sonorous. They ring when struck, with high melting points. Non-metals are the opposite, dull, brittle, poor conductors. But watch the exceptions. Mercury is a liquid metal, sodium is soft enough to cut, graphite, a non-metal, conducts electricity, and diamond is the hardest natural substance. Now, chemical properties. Metals react with oxygen to form metal oxides, which are basic. Copper, heated in air, forms black copper oxide. Sodium is so reactive it's stored in kerosene to keep oxygen away. A few oxides, like aluminium oxide and zinc oxide, are amphoteric. They react with both acids and bases. Metals react with water and acids at very different rates. That's the clue to reactivity. Sodium and potassium react violently even with cold water. Magnesium needs hot water or steam. Iron reacts only slowly, and copper and gold barely react at all. With dilute acids, a reactive metal gives a salt and hydrogen gas, though nitric acid usually behaves differently. Line metals up from most to least reactive, and you get the reactivity series. Potassium, sodium, calcium, magnesium, aluminium, zinc, iron, then hydrogen, then copper, silver, and gold at the bottom. The rule that falls out of it. A more reactive metal displaces a less reactive metal from its salt solution. Iron displaces copper from copper sulfate. Why do metals and nonmetals love to combine? Metals lose electrons to form positive ions. Nonmetals gain them to form negative ions. Sodium gives its electron to chlorine. Sodium becomes Na+, chlorine becomes Cl-, and the opposite charges attract in an ionic bond, making sodium chloride. Ionic compounds are hard, high-melting solids that dissolve in water and conduct electricity when molten or dissolved. Where do metals come from? From the Earth's crust, as minerals. A mineral that contains enough metal to extract profitably is called an ore. Very unreactive metals like gold and platinum are found free, as the metal itself. Reactive metals are always locked up in compounds as oxides, sulfides, or carbonates. How we extract a metal depends on its reactivity. Metals low in the series, like mercury and copper, can be got by simply heating their ores. Metals in the middle, iron, zinc, lead, are first turned into their oxide, then reduced with carbon. And the most reactive metals, sodium, calcium, magnesium, aluminium, hold on so tightly that only electrolysis can free them. 2 words for making the oxide. Roasting is heating a sulfide ore strongly in air. Calcination is heating a carbonate ore in limited air. Either way, you get the metal oxide, which carbon then reduces to the metal. The raw metal is finally purified by electrolytic refining. Impure metal at one electrode dissolves and pure metal deposits at the other. Finally, protecting metals. Corrosion eats them away. Iron rusts, silver blackens, copper turns green. We fight it by painting, oiling, galvanizing, coating iron with zinc, and by making alloys. An alloy is a mixture of a metal with other metals or carbon. Alloys are harder and resist corrosion better. Steel is iron plus carbon. Stainless steel adds chromium and nickel. Brass is copper and zinc. Bronze is copper and tin. Quick check. The question's on screen. Pause if you like, but try it first. 10 seconds, go. In the reactivity series, potassium sits right at the top. It is the most reactive of these metals, reacting violently even with cold water. So the answer is potassium. Option B. And that's the chapter. Metals are lustrous, malleable conductors, while nonmetals are the opposite. Metals react with oxygen, water, and acids by their place in the reactivity series. Metals and nonmetals form ionic bonds by transferring electrons, and metals are extracted by heating, reduction, or electrolysis, then protected by galvanizing and alloying. Free notes with 60 practice questions are in the description. Subscribe to Clarix and keep going.